So the first thing I look at is just some terminology. Now, I don't expect you to write this down word for word. This is where being able to take a screenshot is going to be really important. So take screenshots as we go, so that later when I'm using these words, you know what I'm talking about. Alrighty, so the first thing that we're going to have a look at are terms and what terms are. So terms are the things that make up an expression. If you think of an expression like a sentence, the terms are the words. Now, terms are separated by plus or minus signs, and that's really important to notice that if we need to know how many terms an expression has, we can identify that by using the plus and the minus signs. When we start to simplify our expressions, we need to take into account, we need to know what terms are like terms. Now, like terms are terms with the same variable or groups of variables and the same exponent. And we'll chat about that more as we do more examples, but like terms and being able to identify your like terms is super important. Alrighty. The next thing that we need to know or need to understand what it is a constant. Now, a constant is quite easy to remember. If you think about what constant means sort of just in language, it's something that remains the same. So a constant is a number or is a term that has no variable attached to it. So something like the number 3 or 5 or -4. If there's no letter or no variable attached to it, it's a constant. It's not going to change because it's not being multiplied by an unknown or by that variable. So constant, a term without a variable. Then we need to know what a coefficient is. Okay, so a coefficient is the number that we generally see in front of a variable. So something like 3x, that number 3 is the coefficient to that term. That number is being multiplied with our variable. Remember, there is that multiplication happening between those two things, the 3 and the x. So it also gives us an indication that there is a operation sort of happening over there. And again, coefficient, the number in front of our variable. It's always generally written in front of the variable, so you'll be able to easily identify it. Alrighty, so can I just get a thumbs up that everyone's happy with those 3 things? We don't have any questions about terms, constants, or coefficients. And if you do, obviously, please go ahead and ask.
Let's go, my people. Ah, I see those thumbs up. Well done.
Okay, cool. So the reason I'm saying, like, don't stress about writing it down and learning those definitions is because really you're probably never going to be asked something like that. But what you would be asked are the type of questions we're going to have a look at here in example 1. So it's really important to know what the words mean, so that when I ask you how many terms are in the expression or what is the coefficient of this term, you know what I'm asking. So we've got an expression here of 2x to the power 5 minus x plus 3x squared minus 7 plus 4x cubed. So the first thing I want you to tell me, or want you to be able to answer for me, is how many terms does this expression have? So remember, we said that terms are separated by plus and minus signs. So in the chat, let's see how many terms are we working with here. Right, awesome. So 5 terms.
Sorry,
question?
We have Utandile. I'm not sure if that's a question. Can I take her, or is she?
Cool.
We can.
No, perfect. Okay, awesome, everyone. Well done. 5 terms. So we know that because each of those plus or minus signs separates my terms. So you can see I've underlined my terms so that we know which term is which. And so I know there's 5 terms here. Awesome, well done. So the next question is asking us, what is the constant term of this expression? Now remember, a constant is one that has no variable. Alrighty, so the other thing we need to remember is that each of those signs, and I'm liking what I'm seeing in this chat, each of those terms has its own sign. So if we think about the second term over here, which is the negative x, that negative sign belongs to that term. So if I'm asking you what the constant is, exactly as all of you are saying, it is negative 7. That is the term without the variable, without the letter next to it. And it is actually a negative. So we need to remember that negative sign, which is awesome. You're all doing that. Well done. Righty, so the third question over here, and sort of this is now, like I say, the types of questions you'll be asked with those words, is what is the coefficient of x cubed? Okay, so we now need to go back to our original expression and find the x cubed. Now the x cubed term is this one over here. And the coefficient, remember, is the number in front of it. So what number is in front of x cubed? Awesome, guys. Well done. You are on it tonight. We're all clearly ready to be back at school.
My people are on fire. They're doing it. Well
Alrighty.
done.
So exactly as all of you have said, the coefficient is 4, and you literally just need to write 4. If you want to write plus 4, that's absolutely fine. The only time it's really important that we put the sign in is if it's negative. So if this had been a minus 4x cubed, then it would be really important that you put the minus there. But because it isn't, because it's a plus 4, 4 is absolutely fine. Well done, everyone. That's really, really good. So those are the sorts of questions you need to be comfortable with. And so that's why it's important that you know those, or that terminology, so that when you see a question like this, you don't have to sit and think, oh no, I don't know what a constant is. You know exactly what it is and you can go in and answer. Okay, cool. So can we move on to simplification, or does anyone have any questions? Give me a thumbs up, thumbs down if you're ready to get simplifying.
Are we ready, my people? We look ready. We really do. Well done, guys. Let's vote.
Awesome. Okay, so we're going to, oh no, that's a little bit big, isn't it? We're going to have a look at simplifying expressions. Now, there's a couple of things we need to take into account when we start to simplify expressions. Most importantly is, do I have any like terms that I can add together? But the first thing we always just want to check is, how many terms does my expression have? And this is going to be important later on when we start doing more complicated examples. Right now, it's not the end of the world if you don't sort of think to yourself firstly, okay, this is 2 terms, this is 3 terms, but later on it is going to be quite important. So I'm already seeing some answers here, which is excellent. If we look at this first question, we've got x plus 4x. So the first thing I want to ask myself is, do I have like terms? Remember, like terms are terms that have the same variable and same exponent. So both of these terms have an x. Both of those x's have the same exponent of 1. So these are like terms. Just quickly, unlike terms would be something like 2x and say 4x squared. Even though the variables are the same, the exponents are different. So those are not like terms, right? But I'm seeing that everyone's got this. If we've got 1x or x and we're going to add another 4x, exactly, we have got 5x. Well done. Right, so let's jump straight to question 2. Can you tell me how many terms I have in the expression in question 2? Awesome. 3 terms. Great. So our 3 terms here, those are our 3 terms. No, we don't add the exponent. Sorry, I just see a little question pop up there in the chat. We don't add the exponents because we only change exponents when I multiply or divide. When I'm adding or subtracting, my exponents don't change. Okay, so just remember that, guys. So if we jump back to this question here, 3 terms. Now we want to find our like terms. Now, if you want to, I'm someone who loves to highlight and color and do all of these things. Grab a highlighter and you can highlight as you go which terms are like terms. So I can see that the 2x and the minus 3x are like terms because they have the same variable and the same exponent. Can someone tell me what the word is that we would use to describe the plus 1? What sort of term is plus 1?
So Is that you writing there or it's a student? Guys, please.
I'm not writing at the moment.
Amandla, I saw that it's you writing on the screen. I'm still trying to learn how can I stop that. So
oh, I see it now. Okay, guys, yeah, please let's not write on the screen. I know it's not intentional, but let's just try not to. So whoever's written unlike something, can we take that off? So now all of the answers we're getting in the chat, whilst different, are actually all correct. So the question was, what sort of term is it? In the context of that question, this term is a constant term because it has no variable, but +1 definitely is a positive integer. It definitely is a positive number. But if we're talking about what sort of term it is, it's a constant term. So well done. Okay. Now that I know where my terms are and which terms are like terms, I can add together. So 2x minus 3x is minus x. And then the +1 doesn't have any like terms to it. It's not going to be added or subtracted from anything or to anything. So it just stays as +1. Is everyone happy where we got the negative x and why it's just +1 in that expression? Just thumbs up, thumbs down. Awesome, guys. Well done. Right, so I'm going to let you try the third one by yourselves. Let's see if we can get rid of this writing. So the third question over here is 3x squared plus 4x minus 7x squared. So I'm going to give you a couple seconds to try that by yourselves and tell me or give me the final simplified answer to this. I'm going to see if we can get rid of this writing over here. Jabu, I see a thumbs down. Have you got a question?
I think only Amanda can take it out. I can take it out. Amanda, can you please take out your writing? You can delete it on your side. Yes, Amanda.
I don't know how to take it
out. You don't know how to take it out.
I'm trying to.
There should be an eraser on your side. So you just have to click on eraser and then you just rub it on the screen. Then it should take it out. Try to click on eraser. Okay. Well done, girl. Yes, just like that. But you have to do it in everything, okay? Using that eraser.
It's still showing on my screen.
With us?
Can you still see it?
Yes, yeah. Click on that eraser, but you were erasing. Some of it is done. Yeah. So just click on that eraser and then sort of go over the writing with the eraser so it can erase everything.
It's not doing anything on my side.
Okay, don't stress. No one else writes anything. We'll move away from this. Everyone else, make sure you're doing this question. I can see some answers starting to come into the chat. And I'm liking one so far. Remember, find your like terms and then make sure you add and or subtract your like terms from each other. If a term doesn't have a like term, it just stays exactly as it is. Alrighty, so if we have a look here, we can see that our like terms are 3x squared and the negative 7x squared. And then in a separate sort of group to itself is the 4x, because even though it's got an x variable, it has a different exponent. So it's not a like term to the other two. We then need to add and subtract. So 3x squared minus 7x squared. And be careful here, you have 3 and you're taking away 7. So you're taking away more than what you have. So we're going to end up with a negative 4x squared. And then the plus 4x because it had no like terms to it. So it just stays exactly as it is. And it looks like everyone is getting that. Really well done, guys. Awesome.
Well done, my people. Remember, if you have a question, raise your hand.
Alrighty. Okay, I know we've still got scribbles on the screen, but we're just going to make it work. Right, try the fourth one for me. So identify your like terms, add and subtract your like terms, and then give me an answer there in the chats. Right, and if any,
we can do this.
and if you have questions, maybe raise your hand now while we've got a little bit of time while everyone's working on it, so we can deal with any problems you might have.
Just Samantha, do you want us to stop while the students are busy writing? Because I cannot do it on my side since I'm not the one sharing the screen. I'm sure it's because of that. Because I can't see any option of that. So I will just make you a host. Oh, you are the host. So I'm not the one who's the host. I'm the co-host. That's why I cannot change it.
Oh my great.
Look for that option. Yeah, because you should have the option not to allow them to write on the screen. Like if you go to share screen, you should have that option on the sharing option probably, or somewhere where they won't be able to write on your screen. Let's go, guys. Are we nearly there with this question? Are we nearly finished? I see Faith, you are focusing, girl. Let's go. Kendra, I see you. Busy focusing, that's good.
All right, and don't forget, pop your answers in the chat as soon as you have one.
Let's do this.
Right, so remember, identify your like terms. Those are the ones that have the same variables and the same coefficient. So my like terms here are going to be the 2x to the power 4, the minus 2x to the power 4, and then in a separate group, minus x cubed and minus 2x cubed. And then we want to add and subtract our like terms. So I'm going to wait until I've got an answer somewhere, and then we'll have a look and see if we agree. Anyone want to give an answer to the fourth one? Okay, it is a bit of a tricky one, so let's have a look. So we've got our like terms here, and now we need to add and subtract. So if I just start with the 2x to the power 4 minus 2x to the power 4. Now, if we just take a step back, anytime I subtract something from itself, so 3 minus 3 or 4 minus 4, we know that we always end up with 0. If I take something away from itself, I end up with nothing. So 2x to the power 4 minus 2x to the power 4, they actually just fall away. They end up being 0 because I'm subtracting the same thing from itself. You don't have to write 0 there. If you want to, just remind yourself you're welcome to, but they're gone. Those terms are now canceled out. So we actually only have the minus x cubed minus 2x cubed. And when I go and subtract those two, I end up with a negative 3x cubed. And that is the only thing that's in my answer, because the other two fell away. They cancel each other out. And I'm just left with a minus 3x cubed. Right, is everyone happy with that? I know it was a bit of a tricky one. Do we understand why we just have one term in our answer? Yes, no, thumbs up, thumbs down.
Let's see, my people. Thumbs up, thumbs down. I can see you also writing on the screen. So if you don't mind to erase that, guys, don't play with the screen because we haven't figured it out how to stop you from writing on the screen. I see it's like in between, Teacher Sam. It's in between. So I don't know, anyone who doesn't understand, maybe you can raise your hand up or put your question on the chat and Teacher Sam can sort us out.
Yeah.
Okay.
Definitely a bit tricky, 100%. It's just important to see why these terms cancel out. And so absolutely don't think you need to get it immediately. But yeah, if you've got questions, let's hear them.
Let's go, my people. So you need to ask questions either on the chat or raise your hand so you can talk to us. And also, if you're okay and if you're good, we can move on. It's okay.
Okay, I'm going to move on. If you do decide that you have a question, obviously, just put your hand up or put it in the chats and then we can have a look. All right. So we're going to do this last question and then we're going to take a bit of a brain break, have a stretch, do all of those things. And let's have a look at question 5 here. So there's a lot going on, which again, a little bit tricky, but let's break it down for ourselves. So my first question to you is, how many terms are in this expression? So in the chats, tell me how many terms do I have going on here in the expression? Awesome, 3 terms, well done. Right, I see there's a question for question 4. I'll come back to that in a second. My next question to you is, are all of these terms like terms? So remember, like terms are terms that have the same variables and the same exponents for all of those variables. So while you're thinking about that, the question was just to explain how we got negative 3x cubed in question 4. So if I quickly scroll back to question 4 over here, we got negative 3x cubed because again, if I imagine a number line over here, if I'm starting, we'll get there. If I'm starting with negative x cubed, so I'm starting at a negative 1 essentially, x cubes. I now want to take away another 2. So I already have negative 1 and now I want to take away even more. When I take away even more, I'm going to get to a more negative value, and taking away 2 ends up or leaves me at negative 3x cubed. So that's why I got negative 3x cubed for my answer in question 4. Okay, I hope that helps. Right, if we go back to question 5, I see that we're all saying yes, these are like terms, and absolutely you can put them into order now if that helps you. Now, when we say put it into order, what that means is we want to put it in alphabetical order. So the first term is actually fine as it is because it goes A, B, C. The second term, if we put that into alphabetical order, is negative 2a squared b c cubed. And then I have in my third term minus 6a squared b c squared. And putting it in that order actually really helps us see that these are all like terms. And because they're all like terms, we can now go and add and subtract them. So I see that we've got some, I think the answers are. So I'll give you a second or two to see if you can come up with an answer here when we go and add and subtract all of those terms. So we've got a 4a squared bc cubed minus 2a squared bc cubed minus 6a squared bc cubed. I like what I'm seeing so far. Right, so I'm definitely in agreement that we've got negative 4a squared bc cubed. Now, if you aren't too sure where I'm getting that, again, let's go back to a number line. Obviously, guys, you do have calculators and you're more than welcome to use a calculator. Please don't be scared to use your calculator. That is what it's there for. But let's go back to a number line and see if we can have a look and see what's happening. So I have started with 4a squared bc cubed. So I'm sitting here at positive 4. I want to take away 2 of those. So I'm decreasing by 2. But then I also want to take away another 6. 1, 2, 3, 4, 5, 6. And because I actually end up taking away more than what I started with, I'm going to end up with that negative value. So that's where I get the negative 4a squared bc cubed. Thumbs up if we're all happy with that. Awesome. Great. Okay, so
on fire. Well done, guys.
Let's get up, let's stretch, let's move,
Woo.
touch your toes, do some jumping jacks.
Yes.
Take a little brain break for yourselves. See if you can tell me
guys.
what the burger, the tomato sauce, and the fries represent as values.
Oh, Teacher Sam, you're making me hungry.
Nearly dinner time. Making myself hungry.
So Teacher Sam, while we're busy taking a break, is it okay for you to just stop sharing the screen and restart it so you can get rid of the annotations? I don't know.
Awesome.
Is that okay? Yes.
Yeah,
then
let's
when
see.
you're sharing your screen, you just have to click on the. Okay. Did you manage to get it?
Keep going.
Okay, are we happy that there's no more notations on the screen?
Yay.
Yay.
Thank you. Yes. I hope that
We got there in the end.
Yeah, but I hope you did disable so that they don't write again.
Yes, we figured out how to do it, so thank you.
Perfect.
Yeah.
Okay, guys, so let's see in the chat, what is a burger? What is a bottle of ketchup? And what are the fries? What numbers do they represent? And I'll give you a little hint if you're struggling. Don't start with the first one. See what the other ones are telling you to maybe try and get an answer.
We can do this, guys. When I'm doing this question, I'm thinking of fries from
Okay, so I'm seeing some catch-ups are 8. Absolutely, well done. If we're multiplying 2 of the same thing to get 64, we know that 8 times 8 is 64. I don't think you can see that, so let's maybe do this a bit up. 8 times 8 is 64, so a bottle of ketchup is definitely 8. Well done. Okay, if we're struggling to get to the next one, again, a little hint. Look at what's going on in the second row. You've got 1 times a burger equals fries. This is tricky, so don't stress if you're not going to get it immediately. It's just a little brain teaser.
Yeah, exercise this brain. Let's go. I see Kendra thinking really hard. It's good. Sanele is giving it a try over there.
Oh, yes, I'm liking that. Can you tell me how you got to 25?
Sane, would you like to raise your hand so you can explain to us?
I know I'm putting you on the spot, so if you don't want to, that's absolutely fine.
Yay,
Yes.
Sanele, brave. You're brave. Let's do this.
Hello, ma'am.
Hi.
The reason why I say I got 25 was because if it's obviously 1, it's gonna stay the same answer. So it's basically the same answer for both, for the burger and the chips.
Yes, excellent. Well done. So exactly that. If 1 times a burger is equal to fries, we know that 1 times anything doesn't change the value. 1 times 10 is still 10. 1 times a million is still a million. So the burger and the fries are actually exactly the same, which means that in this first expression, those are exactly the same. And so if we know that the ketchup is 8, well, we can, oh, sorry, I don't know what happened with my 8 there. We can say, all right, well, if I already have 8 and the whole total has to be 58, I can say, well, I'm missing 50. And if I halve 50, because both of these are exactly the same, the burger and the fries are each 25. Well done.
Well done, girl.
I really gave you a bit of a brain teaser there. That was awesome. Well done, guys. Dividing 50 Giving you 25. Awesome.
Woo.
Well done, guys. Our brains are clearly ready for school.
Yeah.
Very happy to see
It's
this.
tomorrow, your brains are ready, guys.
Alrighty. So let's get on with our next example. So again, we're simplifying, starting off a little bit easy if your brain's not tired after that little brain teaser there. So first question, x squared plus 3x squared. Hopefully we can get that quite quickly. So I want to see in the chat what you think your simplified answers. I know no one wants to wake up at 5 a.m., but we're excited anyways.
You guys will be fine. Come on, school's fun.
And maths is great.
Yeah.
Right, I'm seeing some answers. I'm liking what I'm seeing so far. Awesome, guys. Well done. So exactly as you said, we've got like terms here. We can add them together. And so 1x squared, remember there is a coefficient of 1 there. If you want to write it in to help you, absolutely fine. But x squared plus 3x squared, essentially if I've got 1x squared and now I'm adding another 3, I end up with 4x squared. Awesome, well done. Okay, let's have a look at the second question over here. So we've got 5x squared minus 10x plus 2x squared minus 8x. So again, I'm going to give you a little bit of a chance here to go and simplify this expression for me. So have a look, find your like terms, and then in the chat again, let's see what your answers are.
Guys, spicy. This one is spicy. Let's go.
Right, so remember like terms, same variable, same exponent. So we've got the x squareds, and then we have the x terms. Those are groups of like terms that we now need to go and add and subtract. So hopefully that's helping a little bit. Right, I'm seeing some answers. I'm liking what I'm seeing so far. Let's keep going. You got it. Awesome, guys. Okay, so if we have a look, we've got 5x squared plus 2x squared, which gives me a positive 7x squared. And then I've got my minus 10x minus 8x. Now, remember, if you need to draw a number line for yourself, that's absolutely fine. But if you already have negative 10 and you're taking even more away, I'm going to get an even more negative answer. So that's why I end up with a minus 18x. And that is it. Can someone tell me why I can't subtract 18x from 7x squared? Why can't I go and do that subtraction? And put it in the comments, or you can raise your hand and you can explain it. Why can't we subtract those two? Why is that my final answer?
Hey, I see some answers on the charts.
Awesome. So both of those are absolutely correct. They are unlike terms. And essentially, they're unlike terms because of the fact that those variables have different exponents. So one's an x squared, one's an x. They're not like terms. And so I can't go and subtract the 18x from the 7x squared. Well done, grade 8. This is awesome. Alrighty. So let's do this. Let's see number 3. So we've got minus 2x cubed, minus x cubed, minus x minus 2. So remember, identify your like terms and then simplify that expression for me. So I'll give you a second or two again to put it in the chat. And remember, really important that you identify your like terms.
Let's do this, guys. Let's do it. You guys are awesome, by the way.
Yeah, you guys are doing so well. So proud of you.
Faith, I'm rooting for you, girl. I see you. I see you there. Sanile already on the answer. Let's do this, guys. Remember to write it down so you can correct it when teacher Sam corrects us, okay? So we can mark it.
Okay, so just while you're thinking, if you're a little bit stumped, remember like terms, same variable, same exponent. So our like terms here is the minus 2x cubed and the minus x cubed. We then have a minus x. And then what's a little bit new here is we actually have 3 different types of terms. We also have a minus 2, and that's that constant term that we spoke about earlier. So we actually have 3 different groups of terms that we now need to go and simplify. All right, I'm liking what I'm seeing so far. Careful of your exponents, guys. Good. I see some corrections for this yourself. Well done. Awesome, guys. This is excellent. Well done. So the minus 2x cubed minus another x cubed is exactly as you said, the negative 3x cubed. And then because the minus x and the minus 2 don't have any terms that are like to them, we just put them there. They're still part of the expression. We're just not adding or subtracting anything to it, which is cool. We're not always going to do something with every single term or simplify every single term. So our final answer here is the negative 3x cubed minus x minus 2. Right, can we just get a thumbs up, thumbs down on how we're feeling so far about it? There's still a couple more questions, but I just want to sort of see how we're feeling simplifying these things. Yes, lots of thumbs ups.
Oh.
And if it's a thumbs down, that's absolutely fine. Ask me questions.
Mulago, I see you. I see you. We're understanding this, guy. This is good. You have to tap yourself. Well done. Well done. You deserve it.
All righty. So technology and I really aren't good friends. Okay, so here's 2 more questions. Let's see what we make of those. So I'm going to give, let's say 5 minutes. I want answers to those 2 questions. So remember, like terms, add and subtract your like terms. Be careful in question 5, because what we need to remember is that xy and yx mean the same thing. Just because they're in swapped orders or the order isn't the same doesn't mean that they are different. They are exactly the same. They are like terms. The order is just switched. And if you need to rearrange the order of your variables, absolutely go for it. Righty, so have a look at those. As you start to get some answers, put it in the chat. Just remember to number your answer, because I'm asking you to do 2 now. When you say take them down a bit, do you mean like that? Oh, we didn't do question 4, guys. Look at me. Right. 4, 5, and 6. Let's see.
Let's do this, guys.
You're all ready for school. I'm clearly not. My brain is not even counting properly.
Teacher Sam has been teaching us so well, guys, that we understand this. So she's doing well also. Let's do this, guys.
Right, to help you along a bit, I'm just going to highlight our like terms in these questions, or in the first question, just so we can get going, hopefully, and feel confident as we do this. So your like terms here, we've got x cubed terms and we've got some x squared terms. And guys, if you get stuck or you have any questions, please just put it in the chat or raise your hand.
Yeah. Let's see. I can see you, Kendra. You're working hard. Well done. Let's go, guys. I'm sure the rest of you are also doing the same. I'm so proud of this class. Kano, I hope you are there. Ibanati. Fortunate. Let's go, guys. Let's do this.
Okay, so we've just got a question here. Is number in question 6 like term? Utandile, I'm not 100% sure what you mean there. If maybe you can just raise your hand and ask, or try write it out again.
Yeah, Utandile, I'm also not sure, but I think if there is some like terms on question 6.
We definitely have like terms in question 6.
There we go. Let's do this, guys. I see them.
And I'm liking what I'm seeing so far. All right, if you are struggling, I'm going to put down the answer for question 4 here, just so that you can have a look and see what's happening, and hopefully that'll help you with question 5 and question 6. So I've highlighted my like terms. So I've got 3x cubed plus 4x cubed, which gives me, oh, maybe I should not write in a highlighter because that will be very hard to read, which gives me a positive 7x cubed. And then I've got my x squared terms. Now I've got a minus squared plus x squared, which gives me minus x squared. But then I'm subtracting another 2x squared, so I get minus 3x squared. And by the looks of it, we were all getting that, which is excellent. And if you aren't, hopefully that is helping you. Okay, so Utandile, we've got p squared q and pq. So remember, like terms are terms that have the same variables and the same exponent. So have a look there. Do those terms have the same variables and the same exponents, or are they different? And the hint there is look at the p's. Do the p's have the same exponents there, or do they have different exponents? Different, exactly. So that means they are not like terms. Well done. Okay, I see some of you have also done question 5. Keep going. You're doing really well. If you're struggling with question 5, I'm going to highlight some like terms for you. Now, remember, I said to you, just because the order is a bit funny doesn't mean they're not like terms. So even though we've got negative 10yx cubed and positive 3x cubed y, because it's the same variables with the same exponents, they're like terms. And that sort of goes back to Utandile's question there in question 6. X and y, same variables. Both x's have cubes, so they're like terms. And that then means we can add and subtract. So if we go and add and subtract our like terms, 10x cubed minus 4x cubed is 6x cubed. Sorry, my writing's gone a bit funny there. Let me fix it. 6x cubed. And minus 10x cubed y plus 3x cubed y is minus 7x cubed y. Now, just quickly, we are going to mark, and I'll leave these answers up. When writing your answers, if you've got multiple different variables, so like x, y, or p, q, we always try write it in alphabetical order. It's not the end of the world if you don't, but that's sort of just like the convention that we do or write our answers in. Right, I'm seeing some answers for 6. Well done, guys. Let's keep going. I'm going to give you another minute or so for question 6, and then we will have a look. Seeing some good answers here. Well done.
You guys are doing really well. Well done. Why are others on question 8? I might be over one who's that left behind. I can't even see where question 8 is.
I'm impressed because there is no question 8. So
Oh, okay. I think that was supposed to be question 6. Hey, what's that?
I think so.
Because I'm like, what?
Okay, if we have a look at question 6, we can identify our like terms. And remember, I said earlier, check that the variables are the same and the exponent. So p squared q and pq aren't like terms because the exponent for p is different. So we've got 2 different groups of terms that I need to add and subtract here. The p squared q terms and then just the pq terms. If I go and add and subtract 5p squared q minus 2p squared 2 is positive 3p squared q. And then when I get to just the PQ terms, positive 12PQ minus 4PQ is positive 8PQ. Alrighty, so those are the 3 answers that you should have gotten for 4, 5, and 6.